He had seen every kind of performance imaginable, but when this young man began suspending water droplets in midair and creating planets where none should exist, Simon Cowell realized he was about to witness something that would challenge the very laws of physics. The America's Got Talent theater pulsed with its familiar energy, cameras positioned to capture every moment that would become part of television history. Simon Cowell sat at the judges' table, his sharp gaze scanning the stage with the practiced evaluation that had become his trademark over decades of talent judging. The evening had proceeded through its expected rhythm of performances, singers reaching for their dreams, dancers defying gravity in their own ways, comedians mining laughter from everyday observation. Each act had contributed to the reliable flow that kept audiences engaged, some succeeding brilliantly, others falling short of their aspirations. Simon tracked the show's pacing, noting time remaining and the acts still to come. Nothing in the night's previous performances had prepared him for what was about to challenge not just his understanding of entertainment, but his grasp of what was physically possible in the space between Earth and ceiling. His name was Adrian Chen, 23 years old, and he was carefully wheeling something onto the stage that looked like it belonged in a physics laboratory rather than a talent competition. A complex apparatus of metal stands, precisely calibrated instruments, and what appeared to be some kind of electromagnetic field generator filled a cart that he positioned with scientific precision at center stage. Adrian wore a simple black shirt and dark pants, but there was something in his bearing that suggested he belonged more in a university research lab than a television studio. His movements were careful, methodical, as if he were handling equipment that could alter fundamental forces if handled incorrectly. Behind Adrian's equipment cart walked a young woman in a wheelchair, her presence adding an element of mystery to an already puzzling setup. She positioned herself at the side of the stage, clearly an important part of whatever was about to unfold, but her role remained unclear to the audience watching this unusual preparation. Adrian had not always been someone who challenged the laws of physics for entertainment. 6 months ago, he had been a doctoral candidate in theoretical physics at MIT, researching electromagnetic field manipulation and its applications to materials science. His life had been defined by equations, laboratory experiments, and the kind of abstract mathematical thinking that most people found incomprehensible. But Adrian's research had been driven by something more personal than academic curiosity. His younger sister, Emma, the young woman now sitting at the side of the AGT stage, had been diagnosed with a rare degenerative muscle disease when she was 12 years old. By age 16, she had lost the ability to walk. By 18, she required assistance with most daily activities. Emma had always been fascinated by astronomy, spending hours looking through telescopes, learning about planets and star systems, dreaming of traveling to distant worlds. As her physical limitations increased, her fascination with space had intensified. She couldn't explore the world around her, but she could imagine exploring worlds light years away. "I wish I could show you what planets really look like up close," Adrian had told her during one of their evening telescope sessions on the roof of their family's home in California. Not just pictures from NASA, but actually floating in space, seeing how they move, how they relate to each other. Emma had smiled sadly. "Maybe in another life, when I have a body that can travel that far." That conversation had inspired Adrian's shift from purely theoretical research to practical applications. He began exploring whether electromagnetic field manipulation could be used to suspend and control small objects in three-dimensional space, essentially creating miniature solar systems that could demonstrate planetary physics in real time. His initial experiments had been crude, suspending ball bearings in magnetic fields, making metal spheres orbit around central points. But as his technique developed, Adrian discovered he could work with non-metallic materials by coating them with specialized compounds that responded to electromagnetic manipulation. The breakthrough had come when Adrian realized he could suspend water droplets by altering their molecular structure temporarily, making them responsive to electromagnetic fields without changing their essential properties. Suddenly, he could create liquid planets that behaved according to gravitational physics, but existed in the controlled environment of his laboratory equipment. Emma had been his first audience when Adrian successfully suspended 12 water droplets in a miniature solar system, each one orbiting a central sun made of a glowing sphere, the entire system floating in midair without any visible support. "It's like magic," Emma had whispered, watching liquid planets circle their miniature star. "It's like you brought space down to Earth." But for Adrian, the real magic happened when Emma began directing the movement of the suspended droplets. Something about the electromagnetic fields seemed to respond to her presence, her intention, even her emotional state. When Emma focused on specific droplets, they would move in ways that Adrian's calculations couldn't predict. Adrian began to suspect that Emma's neurological condition, while devastating to her motor functions, might have created unusual sensitivity to electromagnetic fields. Her brain, rewiring itself to work around damaged neural pathways, seemed capable of interacting with his equipment in ways that normal neurological function couldn't achieve. Together, they had developed what they called gravitational art, performances where Adrian's technical equipment created the foundation for suspended liquid systems, but Emma's electromagnetic sensitivity guided the aesthetic and emotional content of the resulting displays. Their private performances in Adrian's laboratory had evolved into something that transcended both science, demonstration, and artistic expression. Emma would sit beside Adrian's equipment, her hands resting on specialized sensors that translated her bioelectric impulses into commands for the electromagnetic field generators. As Adrian suspended water droplets in increasingly complex patterns, Emma would guide their movement, creating orbital dances that seemed to respond to music, to emotion, to some kind of communication that existed beyond conventional physical interaction. The idea of performing on America's Got Talent had come from Dr. Sarah Martinez, Adrian's doctoral advisor, who had witnessed one of their private sessions and realized that what she was seeing transcended academic research. "You're not just demonstrating physics," Dr. Martinez had told them. "You're creating a new art form that combines scientific precision with intuitive expression. People need to see that the boundary between science and art is more porous than we imagine." Adrian had initially resisted the idea of taking their work public, concerned that entertainment context might trivialize the scientific principles underlying their technique. But Emma had convinced him that sharing their discoveries could inspire others to explore unconventional applications of scientific knowledge. Besides, Emma had pointed out, most people think physics is boring and separate from real life. Maybe we can show them that the laws that govern planets and stars are the same laws that can create beauty right here on Earth. The stage manager approached them. "Adrian, Emma, you're ready?" Adrian nodded, running through his mental checklist of equipment calibration, electromagnetic field stability, and safety protocols. He had performed their gravitational art dozens of times, but standing here in the wings of America's Got Talent, he realized that no amount of laboratory practice could prepare someone for the moment, when private scientific exploration becomes public performance. Emma wheeled herself to her position beside Adrian's equipment array, her hands finding the specialized sensors that would allow her to guide the electromagnetic fields through bioelectric feedback. Together, they moved onto the stage carrying 2 years of research, a lifetime of looking at stars, and the kind of collaboration that transforms disability into discovery. The audience's reaction was immediate curiosity mixed with confusion. Here was an elaborate scientific setup that looked more suited to a research presentation than entertainment, accompanied by a young man who appeared to be a graduate student and a young woman whose role in the proceedings remained mysterious. Simon leaned forward, his attention caught by the obvious complexity and seriousness of the equipment being positioned on stage. In 15 years of judging, he had never seen anything quite like this combination of scientific apparatus and performance preparation. "Hello," Simon said, his voice carrying clearly across the theater. "What are your names, and what exactly are you planning to do with all that equipment?" Adrian looked directly at Simon, his expression serious but confident. "I'm Adrian Chen, and this is my sister Emma." I'm a physics doctoral student at MIT, and we're going to demonstrate gravitational art, the creation of miniature solar systems using suspended water droplets and electromagnetic field manipulation. The audience murmured with interest and skepticism. This sounded more like a science class than a talent show act. "You're going to create solar systems?" Simon repeated slowly. "Using water droplets." "Suspended water droplets," Adrian clarified. "Using electromagnetic fields, I can alter the molecular structure of water temporarily, making it responsive to magnetic manipulation while maintaining its liquid properties." Emma guides the aesthetic arrangement through bioelectric feedback. Simon was intrigued despite himself. This was either going to be a fascinating demonstration of applied physics or a complete disaster. "And this relates to talent." "How?" one of the other judges asked. Emma spoke for the first time, her voice clear and determined. "I have a degenerative muscle disease that's taken away most of my physical abilities, but we discovered that my neurological condition makes me unusually sensitive to electromagnetic fields. What started as Adrian trying to show me how planets move became a collaboration where science and art combine." Simon felt something shift in his understanding of what he was about to witness. This wasn't just a science demonstration. This was a brother and sister who had transformed disability into discovery, limitation into innovation. "You create art together using physics," Simon said, not as a question, but as an acknowledgement of the remarkable collaboration they represented. "We create impossible things," Emma replied. "Water floating without support, planets that exist only as long as we're creating them, solar systems that respond to emotion instead of just gravitational math." Adrian began activating his equipment, and the theater fell quiet as complex electromagnetic fields hummed to life around the stage. Indicator lights showed field strength, calibration status, and safety parameters all reaching optimal levels. "Whenever you're ready," Simon said, understanding that he was about to see something unprecedented in his years of talent evaluation. Adrian picked up what appeared to be a simple dropper filled with water, but as he squeezed drops into the space above his equipment, something extraordinary happened. Instead of falling to the stage floor, the water droplets hung suspended in midair, each one perfectly spherical, gleaming under the stage lights like liquid jewels. The audience gasped. This was clearly not a magic trick or illusion. The water droplets were genuinely floating, held in place by invisible forces that defied everything they understood about how water should behave. But Adrian was just beginning. He continued adding droplets, each one finding its position in a growing three-dimensional pattern that began to resemble something familiar yet impossible. A miniature solar system with liquid planets orbiting around a central point of light. Emma placed her hands on the sensor array, and suddenly the suspended droplets began to move, not randomly but with purpose, grace, responding to some kind of guidance that existed beyond the visible equipment. As music began to play, a haunting instrumental piece that suggested vast spaces and cosmic wonder, the liquid planets began to dance. Simon found himself completely absorbed in watching something that challenged the basic physics he thought he understood. The water droplets moved in complex orbital patterns, sometimes approaching each other as if influenced by gravitational attraction, sometimes spinning in place like miniature worlds rotating on their axes. But this wasn't just a demonstration of electromagnetic manipulation. As Emma guided the movement of the suspended droplets, the arrangement began to tell a story. The liquid planets formed constellations that suggested human figures, then reformed into abstract patterns that somehow conveyed emotion, longing, the experience of reaching towards something beautiful that remained just beyond grasp. "This is what it feels like," Emma said, her voice carrying clearly through the theater as she continued to guide the liquid planets through their impossible dance. To be held in place by forces you can't control, but still finding ways to move, to create patterns, to be part of something larger than yourself. Simon realized that what he was watching transcended both science demonstration and artistic performance. This was Emma using her brother's electromagnetic equipment to create a visual metaphor for her own experience, suspended between limitation and possibility, creating beauty despite forces that should have prevented any kind of creative expression. The liquid solar system grew more complex, more emotionally resonant. Adrian continued adding droplets, while Emma guided their arrangement into patterns that suggested stories, planets approaching each other like dancers, then separating, water worlds spinning in synchronization like couples waltzing, entire galaxy formations that existed for moments before transforming into new configurations. As the performance reached its climax, something unprecedented happened. The suspended water droplets began to glow, not from external lighting but from some kind of internal luminescence that Adrian's electromagnetic manipulation had somehow triggered. The theater was filled with floating points of light, liquid stars that existed nowhere in nature but here, in this space between science and art, created by a collaboration between a physicist who could manipulate matter and a young woman whose neurological difference had become her superpower. The music swelled, and Emma guided the glowing droplets into a final formation, a perfect spiral galaxy, turning slowly in the space above the stage, each liquid star maintaining its position in a pattern that suggested infinite space contained within the boundaries of a theater. Then, as the music ended, Adrian began deactivating his electromagnetic fields. One by one, the suspended droplets lost their impossible buoyancy and fell toward the stage. But instead of creating a mess, they fell in such perfect synchronization that they created a final moment of beauty, liquid starlight, raining down like the end of a universe. The silence that followed was profound. The audience seemed unsure whether to respond with applause or something more reverent. What they had just witnessed felt too extraordinary for ordinary entertainment acknowledgement. Then Simon did something that surprised everyone. He stood up from the judges' table and began to applaud, not the polite recognition of a skillful performance, but the sustained, amazed appreciation that acknowledges something that challenges fundamental assumptions about what's possible. The rest of the judges followed, then the entire audience. But Simon wasn't finished. He walked around the judges' table and approached the stage, still applauding, his expression showing genuine awe. Adrian and Emma waited, surrounded by the lingering energy of their electromagnetic equipment and the memory of impossible water planets, watching Simon approach with hope and uncertainty. Simon climbed onto the stage and approached the siblings, stopping beside the complex array of scientific equipment that had just been used to create art. "Adrian, Emma," Simon said, his voice thick with emotion, "I want to tell you something." They waited, uncertain whether his response indicated success or confusion about how to categorize what they had just demonstrated. "In 15 years of judging talent competitions," Simon said, "I've never seen anything that combined technical mastery, artistic vision, and pure innovation the way you just did. You didn't just perform, you created a new form of expression." Simon looked at the equipment, then at Emma, then at Adrian. "You took the laws of physics and used them as a paintbrush. You turned electromagnetic fields into poetry. You made the impossible beautiful." Emma's eyes filled with tears, but she was smiling. "But more than that," Simon continued, you proved that limitation can become innovation, that disability can become discovery. Emma, your neurological condition isn't something that holds you back. It's something that allows you to create art in ways that no one else could imagine." Simon turned to address the entire theater. "Ladies and gentlemen, Adrian and Emma Chen have just demonstrated something extraordinary. They've shown us that the boundaries between science and art are artificial, that the most beautiful performances sometimes come from the most unlikely collaborations." As the golden buzzer activated and confetti began falling around them, Simon gestured to the space where liquid planets had danced just moments before. "You created worlds that existed only as long as you were creating them," Simon said. "That's not just physics, that's magic." After the cameras stopped rolling, Simon spent time with Adrian and Emma, learning more about their research, their collaboration, and the journey that had led them from laboratory to theater. "You know what moved me most about your performance?" Simon asked. "It wasn't just the technical impossibility of what you achieved. It was watching Emma guide those water droplets, understanding that she was using your equipment to create a visual representation of her own experience." Emma nodded, her hands still resting on the sensors that had allowed her to communicate with electromagnetic fields. "For the first time in years, I felt like I could move freely. Not my body, but my intentions, my creativity. Adrian's equipment gave me a way to express things I didn't even know I was feeling." Simon realized he had learned something profound about the relationship between limitation and creativity, about how the most remarkable innovations often come from people who are forced to find new solutions to fundamental challenges. 6 months later, Adrian completed his doctoral thesis on electromagnetic field manipulation for artistic expression, becoming the first person to receive a PhD for research that combined physics with performance art. The thesis was groundbreaking not just for its scientific contributions, but for its demonstration that academic research could have applications far beyond traditional laboratory settings. Emma co-authored several papers on bioelectric feedback systems and electromagnetic sensitivity. Her unique neurological response patterns leading to breakthroughs in understanding how the human nervous system could interface with technological systems. Together, they established the Gravitational Arts Institute, teaching others how to combine scientific principles with artistic expression. Their workshops attracted physicists who wanted to explore creative applications of their research, artists who were curious about incorporating scientific principles into their work, and people with disabilities who were interested in using technology to expand their expressive capabilities. The Institute's most successful program worked with young people who had been told that their neurological differences were limitations, teaching them how those same differences might be reimagined as unique capabilities for interacting with technological and artistic systems. Simon's Foundation provided funding for the Institute's research into what they called disability-driven innovation, the idea that people with neurological differences often develop cognitive strategies that could lead to breakthrough applications in technology and art. "Adrian and Emma taught me something crucial," Simon explained during the Institute's opening ceremony. "Innovation doesn't come from perfection. It comes from people who are forced to find new solutions because conventional approaches don't work for them." Years later, when Adrian was offered a prestigious position at CERN working on particle acceleration technology, he chose instead to continue developing gravitational art with Emma, understanding that their collaboration had created something more valuable than any individual career achievement. Emma became one of the world's leading experts on bioelectric interface technology, but she always described her work as learning to dance with electromagnetic fields rather than technical research. The liquid planets that had danced in the space above the AGT stage became the inspiration for a new field of artistic expression. But more importantly, they proved that the most beautiful performances often came from the most unlikely partnerships, the most unexpected applications of knowledge, and the willingness to let limitation become the starting point for innovation rather than the end point for dreams. The water droplets had fallen back to Earth, but the possibilities they had revealed continued to float, suspended in the imagination of everyone who understood that sometimes the most impossible things are just waiting for the right combination of science, art, and the courage to challenge what we think we know about the boundaries of the possible. It wasn't just television that night, it was a demonstration that physics could become poetry, that disability could become discovery, and that sometimes the most profound magic happens when we stop accepting the limitations we've been told are permanent and start exploring what becomes possible, when we refuse to let impossibility have the final word. In the weeks following Adrian and Emma's performance, the video of their gravitational art became a sensation that transcended typical entertainment content. Physics departments at universities worldwide began studying the footage for its demonstration of practical electromagnetic field manipulation that challenged conventional understanding. Dr. Elizabeth Warren from Stanford's physics department wrote, "The Chen siblings' demonstration represents a breakthrough in real-time electromagnetic manipulation. Their ability to maintain stable suspension of multiple water droplets while enabling bioelectric control suggests applications far beyond artistic expression." Adrian received dozens of offers from research institutions, but what moved him most were letters from people with disabilities who had watched the performance and begun to wonder whether their neurological differences might be capabilities rather than limitations. "I have cerebral palsy, and doctors have always focused on what my brain can't do," wrote Jennifer Martinez, a college student from Texas. "But watching Emma control those water droplets made me wonder what my brain might be able to do, that normal brains can't." Reading letters like Jennifer's, Adrian and Emma understood their performance had challenged fundamental assumptions about neurological difference and human capability. The Gravitational Arts Institute grew from these letters. Emma's bioelectric sensitivity became the foundation for developing interface technologies that could translate different types of neurological activity into artistic expression. At the Institute's first workshop in Berkeley, Adrian worked with Dr. Yuki Tanaka to develop equipment accommodating different neurological conditions. They discovered that people with autism, ADHD, and various movement disorders often had unique brainwave patterns that could control electromagnetic fields. Marcus Williams, a 16-year-old with autism, became one of their most gifted gravitational artists. His neurological processing, which made conventional social interaction challenging, allowed him to perceive electromagnetic field patterns with extraordinary precision. Marcus can sense disruptions in electromagnetic fields that our instruments barely detect. Adrian explained to visitors watching Marcus guide dozens of water droplets through complex synchronized movements. His brain processes information in ways that make him uniquely suited for this art form. Marcus's parents watched their son create floating sculptures with water and light, finally understanding that his neurological difference wasn't something to overcome, but something to celebrate. Emma's role evolved from performer to researcher as she worked with neuroscientists to understand her electromagnetic sensitivity. Brain imaging studies revealed that her muscle disease had caused her nervous system to develop compensatory neural pathways. Emma's brain has rewired itself to access sensory information through electromagnetic perception, explained Dr. Sarah Chen. What we initially understood as neurological damage is actually neurological innovation. This research led to breakthrough applications in assistive technology. The Institute began developing electromagnetic interface systems that could help people with mobility limitations control their environment through bioelectric feedback. Simon's Foundation provided funding for a permanent installation at the Exploratorium in San Francisco, where visitors could experience simplified versions of gravitational art. The installation, Impossible Water, allowed visitors to suspend water droplets and guide their movement through hand gestures. But visitors with neurological differences often produced more complex and beautiful results than neurotypical users. "We're not trying to cure neurological differences," Adrian explained. "We're discovering what unique capabilities different types of brains might possess, and how those capabilities might contribute to human knowledge and artistic expression." Years after their AGT audition, Adrian and Emma returned to the show as guest experts. They brought a new development: water droplets that could maintain electromagnetic suspension for hours, creating temporary installations that lasted entire performances. Emma performed a new piece that night, guiding hundreds of water droplets into a formation resembling a human nervous system. Neural networks made of liquid light that pulsed with her brain activity, creating a visual representation of thought itself. The performance was a meditation on consciousness and creativity, showing how different types of minds might perceive and interact with the world. As Emma guided the liquid neural network through patterns mirroring her cognitive processes, the audience witnessed a new form of communication between human consciousness and physical matter. The gravitational art that had begun as a way to show Emma planetary beauty had evolved into proof that remarkable innovations often came from people whose minds worked differently, whose limitations forced them to discover capabilities conventional thinking would never explore. The Institute continued attracting people who understood that difference wasn't deficit, that neurological diversity was human wealth, and that the most important discoveries happened when people who thought differently were given tools to show what their minds could accomplish. Adrian and Emma's collaboration had proven that profound magic happened when science and art combined, when siblings refused to let limitations define possibilities, and when the laws of physics became tools for creating beauty that existed nowhere in nature, but everywhere in imagination. The water droplets continued to dance, suspended in electromagnetic fields that transformed disability into discovery, proving that sometimes the most beautiful impossibilities were just waiting for the right combination of science, love, and the courage to challenge what we think we know about the boundaries between limitation and liberation